Hello, my name is Branko. I'm a creative roads manager here at MikroE, and today, during this webinar session, I will try to explain how you can run simple yet effective two-dimensional CNC router solution remotely. Yes, you heard me well. You will be able to run CNC router remotely just after this webinar session ends. We will provide remote access to the CNC router hardware, and you just have to perform three things. Number one, you would have to run the NECTO Studio, obviously. Number two, you would have to connect to this remote CNC router hardware. And number three, you would have to download and then flash the complete already developed CNC router code solution for this particular hardware. Okay, and you might be asking yourself, well, how can I connect to this remote hardware? How could I connect to the CNC router solution remotely? Well, I'm glad that you asked. I'm just going to transfer myself to the NECTO Studio right now. And just give me a second. Okay, here it is. And after that, you would have to focus yourself on the left-hand side of the NECTO Studio, this vertical toolbar over there, and just click on the code section over there. After clicking on the code section over there, you'd have to perform the focus on the right hand side of the NECTO Studio and focus yourself on the Planet Debug feature. A Planet Debug feature is in essence a planet with a lot of development boards available to you to debug them, hence the name Planet Debug. And now you would type in something like CNC, for example, and you would click go. And after successful connection, you will be presented with the live feed of the CNC router solution. It is a simple yet effective one. There are three motor devices over there, and there are three drivers over there which are going to drive those motor devices, and the final step is basically the complete CNC router controller, which is a development board in the background. Okay, that was all about the hardware part. Now, what about the software part? Where could you get the complete code solution for this CNC router hardware solution? Well, you can just jump back into the package manager over there, type in something just like CNC, and here it is. Here is the CNC router software solution. This package will have two things in essence. The first one is the library, which is going to help us the second thing, and the second thing is the demo example for the CNC router solution. Okay, that would be it. Now the NECTO Studio is doing some things in the background, doing some background checks, and it is doing all in the CMake type logic. And just for a few seconds, we are going to see the code example for the CNC router solution. And just give me a second once again, and here it is. Here is the main.c file, which basically is a CNC router solution demo example. Okay, I'm just going to explain the main functionality of this demo example, and you can get the idea what are we going to do with this CNC router solution from right over here. The first thing that we are going to perform is the CNC init, which is basically the initialization of the CNC components, those two stepper motors and the drill motor device. And after that, we are going to perform the execution of a rectangular drilling pattern. So I have pressed the flash button over there, and I'm just going to switch to the Planet Debug feature over there on the right hand side of the NECTO Studio. And after the programming part is finished, you'll be able to witness the movement of all of those three motor devices. And here they are. The motor device on the lower left is moving, the motor device on the upper right is moving, and the drilling motor is definitely moving. So in essence, This CNC router solution is basically going to perform the cut of the rectangular drilling pattern, okay, on any material. For example, you can do the cut on or routing procedure on a wood, for example. And I think that's it. I'm just going to focus to myself once again. Yeah, okay, perfect. That's it, guys. We can totally finish this webinar right now, because I have provided everything to you guys, and you just can upgrade from here. But if you want to learn how I did the code step by step, so stay tuned, and it will be interesting, and you will learn some tips and tricks along the way. Okay, let's start recreating the solution step by step. First step is the understanding of the CNC hardware. Let's focus on the hardware part, but now in details. So I'm going to switch to the NECTO Studio once again. Okay, perfect. And here it is. We are still connected to our simple two-dimensional CNC router hardware solution. Okay, a stepper motor on the lower left, it can be seen over there, and this one is directly connected to the stepper 22 clipboard, and this stepper motor will basically act as an x-axis of the CNC router solution. Okay, moving on the upper right part of this live feed, we can see the stepper motor once again, but you can see the difference between those two, and I intentionally didn't want to use the same stepper motor as the lower left part stepper motor. I intentionally wanted to utilize some other type of the stepper motor device, because I wanted to showcase the versatility of this CNC router solution. Okay, and this stepper motor, which is on the upper right side of the next live feed, will basically perform as a y-axis stepper motor. Okay, the last motor device that we have to describe is the brushless DC motor. Here it is on the lower right part of the live stream, and this motor device is basically a brushless DC motor device, which is being powered by this brushless 31 clipboard over there. Okay. I intentionally wanted to use the brushless DC motor because it does not have brushes, because brushes plus dust being created from the wood or metal or plastic is equal to low efficiency of the complete CNC router solution. This is why I've selected the brushless DC motor, and of course because of the efficiency of the brushless DC motors when compared with the DC motors with brushes. Okay, that was the explanation of those three motor devices. Now I'm just going to focus on the drivers of those motor devices. Okay, the stepper 22 clipboard is a driver for the x-axis motor device, and it is on the microbus 2 slot. It is very important to remember that. Stepper click is a driver for the other stepper clipboard, and it is on the microbus 3 slot. And once again, there is a brushless 31 clipboard which is on the microbus 4 slot, and this one is going to control the brushless DC motor, of course. Okay, and I intentionally didn't want to populate those three drivers, those three clipboards, starting from the microbus 1. So I intentionally wanted to start from the microbus 2, 3 and 4, and you will see why I have chosen this logic, this population logic, just in a moment. Okay, and the last thing that we have to describe is the CNC router controller, and here it is. Here is the CNC router controller. In the background it is basically a development board, and it is a clicker for STM32F4. Okay, that was all about the hardware part. Now I would like to perform tests, because I want to make sure that this hardware is properly connected. And how are those tests are going to be performed? Well, I'm going to perform dry run tests. I'm going to perform the dry run of the first stepper motor, dry run of the second stepper motor, and finally dry run of the brushless DC motor. Okay, and how am I going to do that? Well, because let's focus on the first one, the stepper motor on the lower left part of the live feed. This one is connected to the Stepper 22 clipboard. So this means that I need a software package for the Stepper 22 clipboard. And now I'm going to do that. I'm going to go to Package Manager, and I'm going to download the Stepper 22 clipboard package. And while installing, we will be able to open this software package, and we will be having two things once again. The first one is the library, which is going to help me run the Stepper 22 clipboard, and the other one is basically the code demo for the Stepper 22 clipboard. Okay, after the initial configuration of the NECTO Studio, which is going to help me run the Stepper 22 clipboard, I am presented with the main.c file, which in essence is a demo example. Okay, first things first, I have told you that I am going to talk about the microbus alignment. Make sure that you properly configure the microbus. So this Stepper 22 clipboard is on the microbus 2 slot. It is not on the microbus 1 slot. This is why I have changed the microbus 1 to microbus 2. Perfect. We have configured the first thing that we have to perform. Now I'm going to explain what this demo example is going to perform. Once again, I need main functionality. Main functionality has two functions in it, application init, so initialization of the Stepper 22 clipboard, and after that the task. I'm going to press the F12 on the application task, and here it is. Yeah, I wanted to showcase one note over there. When you're dealing with the stepper motor devices, you move with steps. So for this particular stepper clipboard, Stepper 22 clipboard, and for this particular stepper motor device, I need 200 full steps to make a full circle. With that being said, this first part of the code will perform the full circle clockwise. The second and the third part will basically present us with a full circle but counterclockwise. Okay, and I'm just going to perform the flash button once again, and of course I'm going to focus on the Planet Debug live feed over there, and we are going to witness the movement of the stepper motor, which is on the lower left part of the live feed. And here it is: full circle clockwise, full circle counterclockwise. And that is it, guys. That was the dry run of the first stepper motor device. Now let's perform the dry run of the second stepper motor device, which is basically going to act as an epsilon or y axis of our complete CNC router solution. Once again, here it is. Here is the connection scheme, and this one is connected to the stepper clipboard, which means we need to get the package for the stepper clipboard to perform the dry run. So once again, go to Package Manager, type in the stepper, and you will get here it is. You will get the stepper click package already, which is going to be downloaded right now. Okay, after the download process, we are going to open the example, and we are going to be presented with, once again, two things: library, software library, which is going to help me run the stepper clipboard, and the example code, which is going to help me perform the dry run of the stepper motor device, of the second stepper motor device. Okay, and here it is. Here is the example code. Once again, do not try not to change the microbus alignment. Just type in my microbus 3 because the stepper clipboard is on the microbus 3 slot of a development system. And let's focus on the main function. Here it is. Okay, once again we have an application int which is going to initialize the stepper clipboard, and after that we have the application task. The application task is going to perform the similar thing just like the previous stepper motor device did, but for this particular stepper clipboard and for this particular stepper motor device, we need only 64 full steps to perform the full circle, in our case clockwise full circle. Okay, and yeah, there are the half steps counterclockwise on the other part of the code, but we have 128 half steps, which means this is going to perform this part of the code, is going to perform the complete circle but counterclockwise. Okay, once again, full circle clockwise and full circle counterclockwise. Yeah, I have pressed the flash button, and now I'm going to focus on the Planet Debug feature on the right hand side of the NECTO Studio. And yes, here we are. We are back on track. We are on the live feed, and now focus on the upper right part of the live feed. The stepper motor is performing the clockwise rotation, and after that the stepper motor is going to perform the counterclockwise rotation. Okay, cool. That was the dry run of the second stepper motor device. Now let's perform the dry run of the third motor device. In our case, this is going to be the brushless DC motor, which is on the lower right part of the NECTO Studio of this live feed. Okay, this one is being driven by the brushless 31 clipboard. So once again, go to Package Manager, type in the brushless 31 clipboard, install the software library for it, and after that we will be again presented with two things: software library for the brushless 31 clipboard and the demo example of the brushless 31 clipboard, which is going to help us run the dry run of the brushless DC motor, which is going to act as a drilling solution for our CNC router hardware solution. Okay, and here it is. Here is the main file, the demo file. Make sure to modify the microbus alignment from microbus 1 to microbus 4. Press Ctrl S on your keyboard just to make sure that everything is perfectly saved. Okay, and after that, let's explain the application task once again. Here it is. And yeah, because we are dealing with the brushless DC motors, we are going to utilize the PWM functionality, pulse width modulation functionality, which means that we have some duty. We have some duty cycle to perform. We are going to start with the 8 times 10, so 80% of the duty cycle in on state, and then we're going to decrement the duty cycle, so 70, 60, 50, etc., etc., all the way down to the 0 duty cycle, which means we are basically going to stop the brushless DC motor. Okay, and after that we are going to pull the brake of the brushless DC motor. We are going to switch direction, and we are going to release the brake, which means that we are going to start to power up the brushless DC motor. Okay, all the way up to the 80%. Switch to the Planet Debug. Just wait for the programming part to finish and focus yourself on the lower right part of the live feed. And now we are going to start looking at the perfect of the movement of the brushless DC motor, which is going to act as a drilling routing of our CNC routing solution. Okay, I'm just going to focus on myself right now. And yes, let's sum up the current state of the webinar. I have showed you where you can find the CNC hardware free of charge. I have showed you where you can find the CNC software free of charge as well. And I have showed you how to perform the dry run of all the components of the simple two-dimensional CNC router. Now I will create a new project because I want to show you how I combined those three click packages, the brushless 31 clipboard, the stepper clipboard and the stepper 22 clipboard into final solution. So once again, I will create a new project and I will pump it with all those libraries and examples. So let's do it. I'm just going to focus on the NECTO here once again. So yeah, perfect. Okay, I'm just going to focus on the project explorer and I'm going to collapse all of those sort of speak, those projects, sort of speak. Okay, after that I'm going to perform the you just have to focus on the left hand side of the NECTO Studio for now, this vertical toolbar once again, and select new. We are creating new project, so this can be called CNC router, for example, project, and I'm just going to click on the next. Okay, the next thing that we have to perform is select a preferred type of the NECTO project. Pro tip over there, stick with the standard project for now. Do not focus on all the other projects at the moment. So standard project, next, and the final thing that we have to perform is selecting a hardware setup. I'm definitely going to use the CNC router solution for now, which has all the preferred hardware that I have already used in the Planet Debug session. So once again, click for STM32F4. GCC for ARM is my predefined tool chain. You do not have to worry about the latest version of the SDK. It is going to be all automatically selected. Yeah, the default MCU is the STM32F407 MCU for this development system. The default programming debugging device is the CODEGRIP device. You do not have to worry about the clock settings. It is all already predefined for you. There is no display, and I will definitely use the application output, which means I can run the debug by pressing F9 on my keyboard, and I will be able to witness all the messages in the application output, which is on the lower part of the NECTO Studio IDE. Okay, after clicking finish, I will be presented with a new project, and then I will start implementing the libraries, brushless 31 library, stepper library, and stepper 22 library into this newly created project. Of course, I will be having a completely empty main.c file, but never mind, I will explain everything during this new project process. So here it is. Here is the CNC router completely clean plate solution, and the first logical thing is inserting the libraries. Okay. How are we going to insert the necessary libraries, the necessary clipboard libraries? Well, I'm just going to jump into the library manager over there, and I'm going to install whichever clipboard library is needed for the CNC router solution. So for our case, stepper library is needed, stepper 22 library is needed as well, and the brushless 31 library is needed as well. Okay, now that we have installed all the necessary libraries, I'm going to perform the next logical thing while developing the CNC router solution. And the next logical thing is creating some configuration, general configuration of the CNC router solution, which means I would like to create a header file, which is going to be called config file, and here it is. And I'm just going to copy paste all the necessary things, and you're going to see, yeah, in a moment. Here it is. Here is the content of the config file. It is not much, but it is going to help us develop a concrete CNC router solution. Okay, and yeah, what is in the config file? For now, we have the stepper speed for the x-axis. We have the stepper speed for the y-axis. Okay, we have a stepper step mode. We're going to use the full step mode. And the final thing is the drill speed, which is going to help me adjust the speed of the brushless DC motor, the drilling motor of the CNC router solution. And I intentionally wanted to limit the power, the max RPM of the brushless DC motor to, let's say, 50%. Okay, that was the content of the config file. The next header file that we want to create is a drill controller header file. Okay, just give me a second. Drill controller header file, and here it is. Because we are dealing with the drill controller header file, the drill or the drill motor that we are going to use is the brushless 31 clipboard. So this is why I have inserted the include brushless 31 header file directive, because we are dealing with the brushless DC motor device. Okay, next logical thing is to explain the functionalities that we are going to use, and here they are. We are going to have drill init, so the initialization of the CNC drill motor. We are going to have the drill enable functionality, and of course we are going to have the drill disable functionality, which is going to disable the CNC drill, which is a very important feature of the CNC router because of the safety. Okay, yeah, and of course the best practice is to use the type def structure. So yeah, I have used the CNC drill type in all of those three functionalities. Okay, the next header file which I would like to create is a let me just give me a second. Okay, here it is. The next header file that I want to create is an axis controller header file. So just give me a second. Okay, axis controller, perfect. And here is the content of the axis controller. Once again, we are dealing with the x-axis and y-axis of the CNC router solution, which implies that I need header files for the stepper 22 clipboard and stepper clipboard. Okay, and after that, yeah, we can just explain what functionalities are we going to use. We are going to have the axis init, the initialization of the CNC stepper motors logic. Then we are going to have the axis move to functionality, which is going to move the CNC machine to a specified position. And the last one, which is very important one, is the axis home functionality, which moves the CNC machine to the home position. Very important feature. Okay, once again, I'm using the type def structure to capture to insert the instances of the stepper X and stepper Y variables. Okay, the last header, I think, just give me a second. Okay, the last header file is the CNC controller header file, and yeah, I'm going to create a header file, CNC controller header file, and I'm just going to paste the necessary content. I do not want to waste your time. This is why I'm pasting the code. Okay, and here it is. Logically speaking, we are going to include the previously created two header files, the axis controller header file and the drill controller header file, because they are an integral part of the CNC router solution. Once again, two functionalities: CNC initialization function, which is going to initialize the CNC system, and after that we have a CNC cut rectangle functionality, which is going to execute a rectangular shape cutting drilling motion. Okay, yeah, that's it, guys. That's it for the header files. Now we need to populate the demo example with some content. Okay, just give me a second. And here it is. Here is the demo example, which is going to perform the which is going to execute a rectangular drilling pattern, and it is going to perform the 100 times 50 step units, and that's basically it. But there is more to it. There are some errors, as you can see, and do not worry about those errors. Those errors are basically telling us, hey, you do not have the board library enabled, and hey, once again, you do not have the log library enabled, and please enable it. And how do you enable those two libraries, the board library and the log library? You jump into the library manager and try to find the board library. Here it is. And try to find the log library over there. Perfect. Yeah, and I think that's it. Once again, we are going to perform the initialization of the CNC components, those two stepper motor devices, and the drilling procedure, the drilling motor device, and after that we are going to perform the rectangular drilling pattern. Okay, after flashing the CNC router controller, I can just move myself to the Planet Debug live feed, and yeah, you will be able to witness the movement of all of those three motor devices just right now. The x-axis motor is going to start spinning, the epsilon axis motor is going to start the spinning, and of course the drilling motor is going to start spinning. And here it is, guys. Here is the movement. Okay, and this is how you perform the CNC router solution remotely with the help of the NECTO Studio and Planet Debug. Okay guys, Q&A session right now, so please do ask anything that you want. You can ask anything about the NECTO Studio, about the Planet Debug, about clipboards, etc, etc, etc. Okay, and I think that we already have some questions, and there is one interesting question from Oliver, yeah. So how does Planet Debug enable remote hardware access for CNC projects? Well, great question. Thanks for asking this one. So at the core of Planet Debug's remote access capability is the CODEGRIP programmer debugging device. This guy over there. So each development system within the Planet Debug is equipped with a CODEGRIP device, which is responsible for programming, debugging and monitoring the connected hardware. The CODEGRIP module is network enabled, allowing remote access via Wi-Fi, effectively opening each development system to users worldwide via NECTO Studio. Okay, I think that I have answered your question, Oliver. You can type in anything that you want. Okay, and there is another question from Oliver. Okay, can I modify the CNC router solution after installing it from the package manager? Okay, that's another question, which is awesome. Thanks for asking that once again. Yes, I encourage you to perform such a task. You can try connecting it via Autodesk Fusion or Fusion 360. It's a very popular platform for 3D modeling. I think that I'm going to perform such a thing down the road during this year, 2025. You can modify the complete logic of the solution as well. You can modify the drilling pattern which CNC router will perform, or even better, you can add some more clipboards, acquire the hardware solution to get to your home, your office, for example, and start building the real project. Okay, That would be the answer for the question number 2. And okay, there is a question number 3 from Edward. Hello, Edward. And he's asking, in majority of your examples you use micro clipboards, but how the code must be structured and designed if a hobbyist does not use micro clipboards? How microcontroller communicates with drivers? Thank you. Thanks, Eddie, for asking this question. It's an awesome question, really. And yeah, I generally use clipboards because they are following the Microbus standardized interface. But if you're working without them, you could structure your code based on the communication protocol. For example, SPI, I2C, UART, etc. And by the way, we already have those those protocols standards in the NECTO Studio. So you do not have to write SPI code, for example, by yourself. So the initialization part for the SPI code does not need to be written by you. So yeah, I'm going to share the GitHub link to already defined drivers, and here it is. So in essence, you can just use those APIs inside NECTO Studio to build the solution without using the clipboard libraries. Okay. Okay, there's another question. Okay, from Oliver once again. Thanks, Oliver, for asking once again. Is it possible to create Planet Debug hardware setup per my request? Oh, that's nice. Just give me a second. Yeah, of course. You can send a query through the NECTO Studio. You just go to the code section on the left part of the NECTO Studio, then connect to the Planet Debug feature, and you could basically click on the custom setups button, and it will redirect you to the following web page. Just give me a second. I want to show you the web page. Here it is. Okay, it will redirect you to this particular web page, and you just click on the setup a request button on the upper right part of this particular website. Okay. Okay, there is another question from Edward. Nice. Also, is USB HID library, like the one from MikroC, still available in NECTO? How can I manage interrupts? Great question, Eddie. Yeah, USB HID library is, yeah, you can connect to the USB HID via the tool which had been automatically provided within the NECTO Studio. So you just go to the of course you run the NECTO Studio, and after that you will be able to select the tools option, and after that you can connect to the USB HID tool set. And about the USB HID library, it is still available, but in the MikroC legacy type of code. It is not available in the SDK type of code. So yeah, it will be available sometime soon, so do not worry about that, and I will inform you about the information. Okay, I think that's it, guys. I think that's it. Thank you for asking all of those questions, and please, if you have some more questions, please write it down right now. I will wait for about 10 to 15 seconds. So please do ask some more questions. And yeah, while I wait for you to ask some questions, I would like to say thank you for each one of you for joining us and being part of this session. If you are interested in upcoming NECTO webinars or want to stay informed about our latest promotions, be sure to check out the following link. Just give me a second. and here it is. Be sure to check out mikroe.com/promotions, where you'll find all the details about the following the upcoming NECTO webinars that I'm going to be host of. Okay, and one important note over there, guys. Just after this webinar session, you will be able to connect to the Planet Debug CNC router solution by yourself, and you just head over to NECTO Studio and start exploring. Okay, I think that's it, guys. Thanks for asking questions, and I think that I'm going to see you once again in the next webinar session. So thank you, see ya, bye.